All right. So in last class, I think we stopped. We discussed till dot product of the vectors, right?
Yes, sir.
We'll be discussing about cross product. Yeah. All right. I think everyone is here now. Oh, Elvin. Okay, they will see it. All right. Anyways, let's start. So cross product. Any problem till last class? See, these things are going to come again and again when we do the application. For example, torque, we will be doing cross product again. Work done, we'll be doing cross product again. All right. So for now, we just want to understand that how this cross product is taken, how you're supposed to do, and how you're supposed to solve problems based on this. All right. So as I told you that there are two different types of product in vectors. One is the dot product, another is the cross product or the vector product. So A cross B is given by magnitude of A times magnitude of B times sine theta into n cap. All right. Now n cap is the vector which is perpendicular to the plane containing A and B vector. Suppose A vector is like this and B vector is in this plane. A vector and B vector is in this plane. So A cross B, how you have to find out, put your palm along the first vector and curl it towards the second vector. The direction of your thumb gives you the direction of the cross product. All right, so what we are supposed to do is, am I visible to everyone? Yes.
Yes,
So
sir.
suppose if I want to find the cross product, I'll put my palm along the first vector and curl my fingers along the second vector. The direction of the thumb is going to give me the direction of the cross product. This is n cap, which will always be perpendicular to the plane containing the two vectors. Pranav, did you understand this? Did you understand this? So suppose if you have x-axis and y-axis. So suppose if you want to find x into y, x is like this, and curl your fingers towards y. What is the direction of your thumb? Towards yourself, no? So this is the direction of the cross product. No problem. The cross product essentially gives you a rotating effect. Okay, cross product essentially gives you what? The sine component of the vector. What is the effect of sine component of the vector? The perpendicular component. So as you know that, we know that if there is a body like this, and if I apply a force, suppose this is a body, okay? So if I apply a force parallel to this body, the body is either going to do linear motion, correct? But if I hinge it over here, and then I apply a force, this will be cancelled off by equal action and reaction. But if I give it a perpendicular force, what will happen? This starts rotating. So how it is rotating about which axis? This axis, no? Did you understand? All right. Let me give you some idea about the axis since we are discussing about rotation. Okay. Suppose, and I want all of you to be interactive. If possible, can you all switch on your camera, please? Because now that we are discussing, I want you people to, can you switch on your camera so that we can have a bit of discussion? Okay. Riya, Pranav, possible? Please switch on the cameras so that we can have a discussion. Okay. Pranav, am I audible to you? Is it possible for you to switch on it, please? Riya, can you switch on your camera for the time being? Okay, while we are discussing this. See, this concept of axis is something which has troubled you even in rotational motion because you did not understand axis. So you did not understand rotation, you did not understand moment of inertia and all that. All right, Ria, can you listen to me? Am I audible? Ria, are you there? Okay, if it is not possible, then let it be, no problem. But if possible, you can just switch on the camera. Okay. Now think about this book, okay? So I'm rotating this book. You can see the sense of rotation. Imagine this is my x-axis. Imagine this is my y-axis and this is the z-axis. So in how many ways can I rotate? Like this. When I'm rotating this book, imagine any point on this book. That point is making a circle. Can you see that? If you can think of any point, think of a point over here. That point is making a circle like this, yes or no? All of you can see that circle is being made like this, yes?
Yes,
And
sir.
where
With the
I'm
Z,
holding
with
this,
the Z axis, right?
yes. So where I'm holding this, is it moving? Is it also making a circle? There are all
Yes.
the points which are making circle, but there is only one point which is not. It is the point on this line.
X-axis. X-axis.
Yes, x-axis, exactly. So this type of motion is called as this type of motion is called as what? All right, Ria, don't worry. Okay. So just you're able to listen to me, right? Can you just give me a thumbs up if you're able, if I'm audible? That's okay, right? Okay. You're understanding? Good. So this type of motion is called as rotation about x-axis. Understood? This is rotation about what? X-axis. Any problem with rotation about x-axis? Now, in a rotational motion, all those points which are at rest, if you join them together, it is called as locus of all the points which are stationary, while all the other points are making circle around it. All these stationary points make up and they have a special name which is called as axis. So this is called as what? Axis. So axis for a rotating body will be all those points which are stationary. No problem. Understood the rotation about the x-axis. If I want to rotate the same book about the y-axis, I need to hold it about y. And this is the rotation about y-axis. Can you all see? All the points are making a circle. Correct. Now to rotate something like this, understand, I need to give a force perpendicular, no? Then only it is going to rotate. If I give a force parallel, will I be able to rotate this? Are you understanding this? If someone is giving a force parallel, so parallel effect is dot product. Now, are you getting a feel of dot product, right? And the perpendicular effect. So perpendicular effect is cross product. No problem. So if there is a vector A and there is a vector B over here, if I'm rotating vector A towards B, the rotation is about this axis. Did you understand? This is how the curl happens. No problem. So this is one type of rotation. This is another type of rotation. Did you understand? And they're opposite to one another. If you're saying, sir, this is clockwise, then this would be anti-clockwise. Yes. Are you understanding this? So when you are doing A cross B, your finger is up. From A, you're moving towards B. But when you are doing A cross B or B cross A, your finger is down. From B, you are moving towards A. So the sense from where you are coming, are you going from A towards B or are you going from B towards A? That is going to determine whether it is going to be plus or minus. Is it okay? Okay, Pranav? Now tell me, X cross Y will be in which direction? X cross Y will be plus Z? Yes.
Yes, sir.
Y cross X will be what? Y
Minus, negative.
minus Z. Did you understand this? Similarly, Y cross Z. Y cross Z will be plus X. See, Y, my hand is along Y, correct? Cross Z, I'm moving it along positive Z direction, will be plus X, correct? Y cross minus Z will be minus X. Can you see this? This is Y. This is your minus Z. So like this, we can draw all the directions. Like this, we can draw all the directions like that. All right. Okay. So like this, we can have all the sense of direction. But when we are saying the motion, look at the motion. Look at the motion. Now, if we are talking about a motion or rotation of this body about y-axis, think about any point. How is the circle? How is the circle? Circle is like this. Circle is like this, right? And how is the axis? Perpendicular to the circle, no? Perpendicular to the plane of the circle, see? Perpendicular to the... If I want to rotate it about Z axis, I'll be rotating it like this. Yes. So how do you get the circle? The circle will be like this, right? And the axis is perpendicular. Can you all see? If it rotates like this, then the circle is in this plane. So the axis is the direction of this cross product. Did you understand? So whenever you get a sense of rotation, there will be a net effect of the sense of rotation. The sense of rotation always gives you a vector quantity, because this rotation is not equal to this rotation, is not equal to this rotation. Did you understand? Did you understand this? And as we go further, we'll understand that just like inertia, which was motion when a body was at rest or when a body was moving, just like inertia, a body will also have a tendency to rotate. Did you understand? A body will also have a tendency to rotate and keep on its rotational motion intact. And that will be called as moment of inertia. That would be called as what? Moment of inertia. I'm sure you must have heard this term. Correct? Moment of inertia. So if I have to tell you about moment of inertia, because all these terms are going to come, cross product is going to come extensively when we do torque. Okay. So when you have to think about moment of inertia, then think it like this, that suppose you take two fans, okay, same from the same company, same color, everything, and you have put it in your room. Both of them are switched on and both of them are running at speed 5. You switch them off together. Now fan A stopped after 10 seconds and fan B stopped after 15 seconds. Which has got a more tendency of rotation? Fan B, of course, because it was keeping on rotating for a larger period of time. So we will say in quantized manner, we will say that what is different in this fan? What is different? It's the moment of inertia. So we will say that moment of inertia of this fan is more than moment of inertia of fan A. Did you understand the sense of rotation, the idea of the cross product? Because many a times you will mug up the formula, you'll learn the formula, but you will never understand the implication of it. You got a feel of cross product, right? Understood? Why this n cap? Why sine theta? Pranav, you understood, no? Okay. So why in dot product we took cos theta? Why in sine? Why in cross product we are taking sine theta? Why dot product was giving me a value of scalar? Why? Because it was along this, right? Force is also along this, displacement is also along this. So the direction is fixed, no? Direction is fixed, right? Either along the direction of the force or along the direction of displacement. But the moment you give the perpendicular component, what happens? The body starts rotating. So if it starts rotating, all the particles will start making a circle. So if all these particles are making a circle, there will be a center of the circle, right? Which will be at rest. And through this center, there will pass an axis. So I need to determine the direction of the axis. Is it going like this or is it going like this? Did you understand? For that, the most simplest way is to find the cross product. And we place our palm along the first vector, curl your finger towards the second vector. The direction of the thumb is going to give you the direction of this cross product. No problem. Clear with this? Okay. Cross product ka funda is clear. All right. Now, how do we find this cross product? There are different ways which you can apply on finding this cross product. Okay. Now, if you guys want, you can switch off your camera. I hope you got the understanding. All right. Oh, just a moment, guys. Oh, great. So yes, so okay, good, good, good. So there is one good thing, guys. I want to show you something. I'll be sharing it with you people now. Can you all see the screen? All of you can see the screen?
Yes, sir.
This people is your short notes, all handwritten for all topics of 11th standard and 12th standard. It's ready. Can you all see this? Yes. Every topic, important topics, all important concepts in few pages. All right. So make sure you take a print of this and keep it with you. Is it all right? For 11th standard as well as for 12th standard also, I think it is getting ready by, so I just gave it to this designer to put the logo and all. But you like it handwritten, right? I don't want it typed. I did not want it typed. That's why I got it in this format. This is good, right? No problem, guys?
Yes, sir.
This is okay, no? Handwritten is okay? All the cases, all important formulas are there. So you don't need to worry about any other thing. So you can see that I'll be sharing this in the group as well. Okay. So you'll get that. All right. Coming back to our point. Cross product. Let's continue with cross product. So when you find a vector, which is given as ax I cap plus ay j cap plus az k cap, and there is b vector, which is bx I cap plus by j cap plus bz k cap. There are many methods to find the cross product. So if they're given in component form, which most of the cases it will be, a cross b will be given by, you need to find the determinant. You need to write I, then j, then k, then write plus, minus, plus. Write the first vector ka component ax, ay, az. Write the second vector ka component bx, by, bz in the same arrangement. Now, you need to take the first value, that is I. So the moment we take this guy and this guy disappears for us. So plus I, along with that, what will come? Cross product ay bz minus az
BY.
by. All of you know this, right? Satvik, you know this, right? How to solve a
Sir,
determinant?
just start in school.
Sir, I don't.
Satvik, you have problem in this?
No, I don't know this, but
Okay. Okay, either you can go with this method. This is called as determinant method. Okay, determinant. Okay, finding the determinant. If you don't know this, then there is another simpler way. Either you can go with like this: I, J, K, cross, cross, cross. So I cross J is what? K. Did you understand? K cross I is what? J. But if you are going ulta, it should be minus. I cross K is minus J. Did you understand this? Just draw a
yes, sir.
circle. Go with I, J, K in the same order. I cross J and go on writing. I cross J is equal to K. See, I cross J is equal to K. All right. K cross I will be equal to what? J. Did you understand? No problem. J cross K will be equal to I. Ulta, if you are going, I cross K is equal to minus J. Did you understand? Pranav, now you understood this? Satvik?
Yes, sir.
Okay. Because see, anything you're multiplying 2i plus 3j, let us say, and 3i minus 2j, let us say, or plus 2j, let's say. Like, let's say we have to multiply this. This is a vector and this is b vector. I need to find the cross product. So number with number multiplication is not a problem, because if I'm multiplying a into b, 2 will be multiplied with both first. So first 3 into 2 times I cross I. I cross I, the formula is I into sine theta, and the angle between I and I is 0, right? So I cross I is 0, J cross J is equal to 0, and K cross K is equal to 0. Understood this? Okay. This is the vector multiplication. No, this is just some scalar multiplication. Understood? Satvik?
Yes, sir.
Okay. So you'll get all those formulas in the notes, so don't worry. Okay. Everything is there in the notes.
Sir, if we get 0, then the whole term will be 0, right? 3 into 2
Of course,
into...
this entire, yes, this entire term will be 0. So you get what? Plus 2 into 2, I cross J. I cross J. What you have got? I cross J is nothing but equal to K cap. So 4 K cap. Did you understand?
Yeah, sir. But in the previously we just multiplied the corresponding terms and we got the answer, right?
Because it was dot
There it
product,
was
cos
okay
theta.
in dot product. Okay, the
Here
components
it
are
is
different,
sine
right?
theta.
In I into J, I into I is different, and then all the stuff are
Correct.
different.
Correct. Understood this? Understood this? Yes. Clear? No?
Yes.
Okay. So cross product is clear. No problem. Now this is, guys, this is the basic of vectors. Now I'm not saying that with the basic idea of vectors you'll be able to solve all the problems, because as we go ahead, for example in JE there will be a lot of problems which are related to two-dimensional motion. So vector will come again. Again, vector is a quantity which deals with forces and everything else, right? So again it is going to appear when we deal with forces. Again we'll meet dot product when we do work done and all. Again we meet with torque product, the cross product when we do either angular momentum or we do the torque and all. Okay, so it's not that you have done it once and forever it is over. Got it? But for now, at least for the starters, I think now you people are comfortable with vectors. Yes? Comfortable with vectors, guys?
Yes, sir.
Okay.
Sir,
Now,
uh,
yes.
so I just had a doubt. So I understood how to solve them. So, but could you explain how um vectors, like the perpendicular effect of the
Mm-hmm.
vectors, like how exactly does it work?
Okay. So if they perpendicular effect, how exactly does it work? For example, we have seen a torque on a dipole. There was a charge QE, remember?
Yeah,
And there was a dipole moment vector. There was
yeah,
an electric field. So imagine the electric field, the center of the electric field is over here. The net force is 0.
yeah.
So this electric field is trying to rotate this guy in this direction,
Yeah,
correct? So this P vector is trying to rotate itself towards ES. So what is
yeah.
the net effect? Net effect is P cross E, no? Which is a
Okay.
rotational effect, which will be along this axis, perpendicular to this guy, yes?
Yes, sir. Yeah.
So did you understand? So this P
So
vector,
that's perpendicular outside, right? I mean, sorry,
yes,
into the
of
plane,
course,
into the plane.
into the plane or out of the plane, perpendicular to the plane containing the two vectors.
Okay.
Perpendicular, this is P vector, this is E vector, this is angle theta. Whatever it is, one thing is sure that if this is the plane in which this vector, these two vectors are, the vector would be, depends whether it is moving clockwise or anti-clockwise, depends whether it is electric field is in this direction or that direction. But one thing is sure that the axis will be perpendicular because the motion will happen like this. Because
Okay.
from first vector, if you try to move your fingers in the second vector, that will be perpendicular to the plane containing the two vectors.
Yes, sir.
Understood?
Yes, I got it.
Okay, so any rotating effect, any rotational effect, you are going to see the effect of cross product. So this is going to come again and again and again. So don't worry. Even when we move into magnetism, we'll see force, and because of all these wires and all that, force because of a current carrying conductor on the other, it is I into L cross B and all that. We'll do that. Don't worry.
Okay, sir.
Okay. So many a times it is going to appear. Now the next thing is either we can go for units and dimension. Okay. So as of now, don't try attempting all the questions of vectors. I'll tell you when to attempt. After two-dimensional motion, you will be good enough to attempt any question of vectors after we have completed. So now we have got two options going further. Either we can start with units and dimensions, or we can go for motion in one dimension. What do you guys want to do?
Sir, I'm okay with motion in one dimension.
Rishi, Satvik, have they taught you units and dimensions?
Sir, what's there in that? They don't tell the names actually, they just teach it. So
So it's like basically unit, like meter, kilogram,
that
dimensional quantity, mlt to the power minus one, dimensional
then
formula of.
I've not learned.
Have they done it?
No, they haven't.
Oh, okay, all right. What about you, Rishi? What do you prefer?
So I'm fine with either of them because we've already done units and dimensions in school. But we
Yeah,
can
units and
do that, no problem. I don't have a problem with
Okay.
either of them.
What happened?
So I don't have a problem with either of them. It works.
Okay, Ria, you're okay with units and dimension? Because for NEET, so definitely it is very important. Okay. So by units and dimension, I mean error and everything. Okay. All right. Cool. So let's start with units and dimension, U and D. Now, if you talk about any quantity, any physical quantity. So the quantities are of two types. Okay. The quantities, let me just open the camera for some time. Can you all see me? Yeah. So see, quantities are of two types. One is a physical quantity, another is a non-physical quantity. Physical quantities are those quantities which can be measured, and non-physical quantities are those quantities which you cannot quantify, which you cannot measure it. For example, measurable quantities is like length, mass, time. You can say 5 kilograms, 10 kilogram. 10 kilogram will be more or 5 kilogram will be more, that you can debate. You'll have 10 meters and 50 meters that you can debate. But non-physical quantities like emotion, anger, love, hatred, can you measure that? You can't say today I am 1.35 times more angry than what I was yesterday. Can you say that? Can you quantify? Not possible, right? Okay, guys, keep responding. Okay, when I'm taking the theory part, please keep responding, otherwise I won't know whether you're listening to me or you're sleeping. Okay, so did you understand? So all these emotions, anger, love, or whatever you say, care, which cannot be quantified, are called as non-physical quantities. Now, since non-physical quantities cannot be measured, we don't go to that part. So we only talk about those quantities that can be measured. Okay, Satvik? Okay. So those quantities that can be measured are called as are called as what? Physical quantities. Now, in physical quantities also, we say that there are fundamental quantities and there are derived quantities. For example, fundamental quantity like mass, length, time, which cannot be expressed in any other form. You can't express mass in some other form. You can't express length in some other form. So these are basic quantities, fundamental quantities. Initially, we used to have 3 fundamental quantities. Now we have 7 fundamental quantities. So derived quantities are like density. Density depends upon mass and volume. Volume again depends upon length, right? So if I have to say that how many dimensions of mass is there, so mass is one time, and how many times length comes, because if it is volume, it will be definitely, like suppose if I'm talking about a cube or anything, it will be 3 times the volume in terms of cube, right? 4 by 3 pi r cube or a cube or anything like that. All right, so these are called as derived quantities. All right, now we have, at this point of time, we have 7 fundamental quantities, and we have different sets of units. So you know that we were ruled by Britishers. They introduced something called as FPS system. They told, okay, the fundamental quantities you are going to measure, the length in foot, the the weight will be measured in pounds. Even now, when we order the cakes and all, we say no, that this is 3 pound ka, 4 pound ka, something like that. We say it, right? So, and S is seconds. So time is always measured in seconds. So foot pound second system, then there is a CGS system, centimeter gram second system, and then there is MK system, right? So mass kilogram second system. So or meter kilogram second system, sorry. So when you talk about all these different types of system, the system is only relevant when you're talking about that type of a data, that type of a value. For example, I ask you, Pranav, that Pranav, what's your age?
16.
16 what? 16 seconds.
16 years.
See, any quantity without a unit has got no significance at all. Did you understand? Did you get it? Okay.
Yes, sir.
All right. So if you want to go and buy sugar, and your mom tells, buy five sugar. 5 what? 5 molecules. What 5? 5 spoon. What 5? So any quantity has got no meaning, absolutely no meaning, until and unless the unit is mentioned. Now, when you're telling me years, it becomes a easily calculatable value for me. That is why I accept year as a standard unit of age. No problem. Did you get it? Okay. But if suppose if I have to monitor something which is like really, really fast, for example, if I want to know that how much time will or how much time does a batsman get to hit a ball? All right. So by the time it is released from a bowler's hand, how much time a batsman gets to hit it? All right. If you tell me that time in years, will I be able to calculate? Did you understand? So it has to be relevant. It has to be, for example, from here to Delhi is let us say 800 kilometers. Now, if somebody starts telling me from here to Delhi distance in centimeters, that is just irrelevant. All right. That is why we have got different system of units. So we have MKS unit, we have CGS unit, and we have FPS system. And there was a lot of confusion with regard to these different system in the scientific community, because people were measuring something and they were writing in CGS, some were writing in FPS. And while I was in University of Hertfordshire, I was actually in Department of Aerospace Engineering, and a very interesting case came up, and it was a part of my research project. I want to share that with you people because it's really important. So you know what? There was a cargo flight which actually crashed. Okay, it was a very unfortunate event, and I was a part of the review team, and we figured out that because of a simple mistake, hope like luckily nothing happened, like nothing serious happened. It was just a training flight, and they got just little bit hurt. But then when we figured out that what was the problem was the conversion. Instead of liters, they filled it in meter cube or something. They did some mess up in the unit, and that is why the plane just took off with half of its fuel. Are you getting my point? Okay. So units are really important. Now, when we talk about all these units, what we need to understand is that how many times a fundamental quantity appears in the main quantity. For example, if I talk about velocity, if I talk about what velocity, so I have got all these 7 fundamental quantities, right? I have got all these 7 fundamental quantities. So I have like mass, length, time. I have like mass, I'll be writing it as m, length is l, time is t. If I have to write velocity, velocity will be distance by time, so L by T. This is called as dimension. When you write it like this is called as dimension. But when you write all the three, minimum 3 fundamental quantities, that is m to the power 0, L to the power 1, T to the power -1, and put it in the square bracket, this is called as dimensional formula. This is called as what? Dimensional formula. No problem. Now, fundamentally, every equation has to be dimensionally homogeneous. What is the meaning of dimensional homogeneity? It means if I'm writing S is equal to UT plus half AT square, every quantity has to have the same dimension. S is the distance, so it should have the dimension of length. U is the velocity, L by T. T is the time, T, plus half this constant, so there is no dimension. Acceleration is L by T to the power -2 and T is T to the power 2. So you see, did you understand? Did you understand this, guys? Which means every quantity should be dimensionally homogeneous. You can add only length to length, time to time, mass to mass. You can't add mass to time or mass to length. Got it? And the first type of questions that they ask you is based on this principle of homogeneity only. Understood this, guys? Yes?
Yes, sir.
Okay. Okay. Now, if you can just take the book, take out page number 1 for all the NEET guys. Take out page number 1 and you can see the questions. The question is x equals to at plus bt square. X is the distance traveled by the body in kilometers and t is the time in second. Then the unit of b is, what will be the unit of b? Which means every term must have the same value, right? So how do we find the unit? Just try out these 5 questions We come back after 10 minutes and we continue with units and dimension. We also have to go to accuracy and precision. All right, guys, join back fast. Cool. Rishi, you can stop recording. And then once we are back,